So yesterday we talked about arithmetic sequences. That just means number sequences. Okay, so on this first one, where do I start? 25. And now I want to find the difference between 25 and 20.
Minus 5.
Minus 5. And then difference between 20 and 15?
Minus 5.
Minus 5. Difference between 15 and 10?
Minus 5.
Minus 5. So what was our rule or our pattern?
Minus 5.
We're subtracting 5 the whole time. What was my first term? 25. Okay. What you're going to realize today is that the first term and our pattern are the two most important things of a sequence. Okay, because you need the first term to get the sequence started, and you need the difference to know how the sequence is moving. Okay, so biggest thing to know is your first term and your difference. Okay, so that sequence we were working with, we're going to write this as a recursive formula. So you don't need to rewrite this. I just want you to fill it in. We'll do this one together. Okay. In that first sequence, what is my A1? 25. Remember, A1 is my first term. So A1 is 25. What is my difference? Minus 5. Yep, we want that negative with it. Okay. Those are the two most important things. That's all I need to know to write the formula. Okay, so now to write the formula, we just need to plug those values in. So we have AN equals, well, what did we say A1 was? A1. A1 is 25, where N equals 1. Why do you think we put N equals 1 there?
Because N equals 1.
Right, because the first term in A1, remember, that's where you get the N value. So A1 is our first term where N equals 1. Okay, so remember, whatever number this is, that's the N value. And then this part right here, that's always going to stay the same. So we have A to the N minus 1. And then what did we say D was? Minus 5. Yep. And then for all the other values greater than 1.
Is that the answer?
Yep, that's how we write the formula.
That is.
Yep. So nope, not yet. The first equation right here, the first function, that's when N equals 1. So can I put, if I'm looking for the fifth term, can I say the fifth term is 25? No, because this right here is only for the first term. This bottom part right here, this is for all of the other values in the sequence. Okay, so this is your starting point, and this is for all the other values in the sequence. Okay, with this formula, all we're doing is just writing it. Okay, the other formula is where we're going to use it. Go ahead and try B. This one right. Oh, that one wasn't a sequence, right? Never mind. Let's talk about formulas. We're going to talk about two formulas. One's the recursive formula, and then the second one is the explicit formula. Recursive. What is a piecewise function?
No idea.
From last week. Piecewise function. Piecewise function is what? How many functions are in a piecewise function?
2.
At least 2, right? 2 or more. Okay. So we're dealing with a piecewise function, and these, there's only going to be 2 in them. Okay. So to write the piecewise function, go ahead and write this in your notes because it's not in there yet. So you're going to want to write this down. This is our recursive formula. So A to the N. And then your first function is A1 where N equals 1. And your second function is A to the N minus 1 plus D where N is greater than 1. Write that down. You're going to want that later. Okay. Talking about notation real quick. When they're talking about sequences and they don't have a sequence, they use this form. They go A1, A2, A3, all the way to AN. Now let's talk about that real quick. A1 stands for your first term. A1 is your first term. What's A2? Second term. Third is A3. What do you think this AN stands for? The last term. AN stands for any term in the sequence. Okay, so if I'm talking about this first term here, A1, that AN turned to A1, so we know that N equals 1. Does that make sense how I got that? because in the n spot, there is the 1. So for A2, what would my n value be? A2, my n value is 2. A3, my n value is, okay? So if I'm talking AN, like I wrote up here, AN, and that equals, I'm going to say A1. Your n value is that subscript. Okay, so for A1, my n equals 1. So for A2, my n equals 2. Okay, so whatever this, so if I have A7, whatever this number is right here, that's my n value. Okay, so A7, my n value is 7. Thank you. Okay, back to this formula up here. So, like I said, two most important things we're going to find. We need to know what A1 is, and we need to know what D is. D is the difference or the pattern. Okay, so we need to know what A1 is, and we need to know what D is. So going back to this example right here, we already found what the difference was, right? Yesterday? We did this example yesterday, should have. Okay, go ahead and write the recursive formula. So this, you're just filling this in. What'd you say? A, the 103.99. Example 2A in your notes. So again, you're following this. You're going to fill it in just like we did before. So use that formula, fill in what you know. Okay, again, what are the two most important things to write the formula?
The first number and the sequence.
First term and the difference. We're going to call that difference. Yep. So first term and the difference. So let's find those first. What is A1?
103.
103. What is the difference?
Minus 4.
-4. Yep. So now we're just taking those and plugging them in. Okay, just like we did with substitution last week. So if I write this, what do I write on the top?
103, comma, n equals 1.
Yep. And again, what does this n equals 1 mean?
It's the first term.
It's the first term. Yep. What do I write in the second part?
A n minus 1 minus 4, comma, n greater than 1.
Yep. Little hint for you. These intervals will always be that. Okay, those intervals will always start at 1, and then it'll always be greater than 1. Okay? The only thing that's changing when you write this formula are your first term and your difference. Okay, just dependent on what those numbers are. Okay? Let's move on to explicit. Okay, with explicit, you're going to want to write this formula down in your notes also.
Where's this at?
The explicit formula, so we're on example 3, but this part's not in your notes. So write this formula down somewhere by example 3. We have AN equals A1 plus D times N minus 1. This formula is a version of the recursive formula, but this formula allows you to find any term in the sequence. Okay, so if I asked you to find the 76th term, you could figure that out by using this formula. Okay, so let's talk about it. What are the two most important things again? First number, and the difference. Same thing. This is where n comes into play. Again, what does n stand for?
First number.
A1 stands for first number. What'd you say? The number at the bottom, right? So if I say n is 12, or sorry, I'm going to switch that. If A15, what is my n value?
15.
15, good. Okay, so now this is where n comes into play. Okay, so let's look at this example right here. Pretend they haven't written it down yet. Okay, we're going to write the explicit definition from our recursive formula. So they're given this, our recursive formula. Remember, what is my A1? What is my first term? Looking at this formula right here. What is my first term?
16.
It is 16. Yep, because it's plugged into the A1 spot. What was the other important thing? The difference, in which is negative 3. Good. Why do we have to have the negative 3 and not just 3?
Because it's negative 3. Yeah, 'cause it's negative.
Because it's going down. We have to have that negative with it. Okay? So we have both. Now we need to write the explicit definition. So remember, we're following this formula now. AN equals A1 plus D times N minus 1. So we're just plugging in values again. We don't know what AN is, so I'm going to keep AN. What's A1? 16.
Negative 3.
Minus 3. And then we have N minus 1.
Is that the answer?
That's how we rewrite it. Now let me ask you this. If I wanted you to find the fourth term of the sequence, so I wanted you to find what A4 was.
Oh, it'd be N
How would I find that?
N minus 4, right?
We have N minus 1.
But wouldn't it be 4 though?
Right, where did you get that?
The A4 in the beginning.
Right. This tells you that what? What does that tell you?
Tells you the N value.
That tells you the N value, right? That tells you that N is 4. So then we can use substitution to figure out what A4 is.
So it'd be 4 minus 1.
Yep, so, but we have to plug it into the whole formula. So we have 16 minus 3 times 4 minus 1. So then 4 minus 1 is 3. And then we still have times negative 3.
Negative 9.
Yep, so 16 minus 9 would give you 7. So that told me that the fourth term in the sequence is 7. So that's what the explicit definition is used for, to find other terms in the sequence. I could ask you find the 176th term, and you could figure it out, because where would you plug in 176? Where the N is, right? Yep. So this value right here, this is just telling you what number in the sequence you're looking for. Okay? One more example here. Oh, go try A and B on your notes. So on A, it gives you the recursive. It wants you to write the explicit. So on A, I want you to write this formula. This is the explicit. Go from the recursive to the explicit. And then on B, you're going from explicit to recursive. Again, what are the two most important things of sequences?
First number and the difference.
First number and the difference, okay? In A, the recursive formula, so I'm looking at this one right here. What is, well, do I know what AN is? No, AN is just what we start with. What is my A1? 45. What is my difference?
Negative 2.
-2. And then do I know what N is?
No.
No. Any questions on rewriting that one?
Is that the answer?
Yep, that's all we're doing is rewriting on this one. Yep, so that's the answer. On B, it gives us the explicit right here. I want to rewrite it in the recursive form. So I start with AN. What do I write on the top? What's my A1?
1.
A1 is 1 because it's in that A1 spot. So we have 1. And then what's my interval?
N minus 1.
N minus 1 or N?
Plus 1 equals 1.
Equals 1. Yep, because remember, first term is when N equals 1.
Okay.
Okay? And then what do I write on the bottom?
N minus 1 plus 7 N greater than 1.
Good. And then he got that 7 from the where the difference is in the equation. And then that's all we do. We're just plugging that in. Okay? Let's do another practice. On this formula right here that we rewrote, if I asked you to find the 6th term of the sequence, go find it. Go find it. Okay, so if I'm finding the 6th term of the sequence, what am I looking for? What would my AN be now?
A6.
A6. So then I'm still using this formula right here. So I have 45 minus 2. Well, what's my N value?
6.
6, because remember, N is always going to match whatever term you're looking for. Okay, and then we have minus 1. Now we solve 45 minus 2 times 6 minus 1? 5. Keep going. So we have 45, negative 2 times 5? Negative 10. 45 minus 10. 35. So my sixth term in the sequence is 35. Okay.
Where?
Example 3, A and B. This one. So here it tells us she runs 1 mile the first day. Again, what is the two most important things in the equation? A1 and A1 is the most important and the difference. Okay? So she runs 1 mile in the first day. What does that tell us?
Bless you. Thank you.
What's the first day? A1, right? And A1 is 1. Does that make sense to everybody?
Yes.
The first day she ran 1 mile.
I could not do that.
Okay? I'm going to change this. On the 7th day. On the 7th day, she ran 43 miles.
What?
So, on the 7th day, she had ran 43 miles. How do I notate the 7th day? How do I notate the 7th day? A7, right? It's day 7. And how many miles did she run? 43. Okay. So A7 is 43. That's all the information we know. So what do we not have?
D.
We don't know the distance. Okay? We can find it by using the explicit definition. So again, we have AN equals A1 plus D times N minus 1. So using substitution, we just need to plug in what we know. Okay? Do we have a specific AN other than A1?
43.
Which is A7. Good. What is A7 equals what? 43. There we go. A1 is what? 1 plus, do we know what D is? No. Do we know what N is?
Yes.
What is it?
43.
It is not 43. 7. Yep.
So where'd that 43 come from then?
43 is how many she ran that day.
But why'd you put it instead of the A7, why'd you put 43?
Because it's 43.
Because on day 7, she ran 43. And remember that N equals 7. Because N is the day. So we just need to solve for our distance or our difference. Okay, so we have 43 equals 1 plus, what's 7 minus 1?
6.
6. And then we still have D. How do I solve for D?
Minus 1.
Minus 1 on both sides. So we have 42 equals 6D.
Divided by 6.
Divide by 6 to get D equals 7. Yep. So difference is 7. Now, could we find any other term in the sequence?
Yes.
Because why?
They involve numbers.
Because we have A1 and we have the difference, right? So we have both of those terms. We can find any term in the sequence. Go find what she ran on day 11.
Oh, I thought you were going to say 19.
Nope, day 11. What did she run on day 11? So you're looking for A11. Okay, I think what confused us is because we started with this A7, right? But once I go to a new term, do I care about this one anymore? No. Okay? The only reason we used A7 was to help us find what our difference was.
So do we still want A1?
Okay? Yep, we always want, remember, most two important things. We always want A1 and we always want the
So
distance.
we can get rid of that. A1.
Okay? Yep. So looking at this formula right here, we're looking for A11. Okay, so I'm following this formula. Following this formula right here. I plugged in A11. What is my A1? 1 plus, what is the difference? 7, we just found it. Times, do I know what N is?
Yes.
What is it?
11.
Yep, comes from right here. N is 11 minus 1. So now we just solve 1 plus, what's 11 minus 1? 10.
70.
Yep, 1 plus 70 is 71. So by the 11th day, she ran 71 miles.
How many miles did you
Okay.
run per day?
What I want you to back of your notes, I want you to do number 6. This one right here. You're going to write the recursive formula and you're going to write the explicit. So you're going to write both formulas. Okay? On these, how do I figure out what A1 is? If it gives you a sequence, how do I know which one A1 is?
It's the first number.
It's the first number, right? So our A1 is 6. What else is important?
Distance.
Difference or distance. 6 to 1
Minus 4, 5.
minus 5. Check if it's the same.
Yes.
Is it?
Yes.
Is it the same all throughout?
Yes.
Okay. So our difference is minus 5. Do we have everything in order to plug in the formula?
Yes.
Yes. Okay, so all you're doing is just rewriting. So AN equals, what do I write on the top? 6, and then the interval,
N equals 1.
N equals 1, bottom,
AN minus 1 minus 5. N is greater than 1.
good. That's it for that formula. Now the second formula, AN equals 6
Minus 5.
minus 5,
Parentheses, N minus 1 parentheses.
good. Okay, now some of you asked me, it was a good question, if I have to solve for anything. Did I tell you any specific number to solve for? Like, did I ever say N to the find N7 or A7?
Can you find it?
No, right? But if I ever ask you a problem to find what someone give me a number.
15.
A15. Go find A15 using one of those formulas. Which formula should you use? So, the second one, right? Find A15 using that formula. Okay, so if I'm asking you to find A15, what is that asking?
15.
15th term in the sequence, right?
Yeah.
So how would I use this in this formula? I have 6 minus 5. Do I know what N is?
15.
Yep, it comes right from whatever term you're looking for. 15 and then minus 1. So we solve 6 minus 5. What's 15 minus 1?
14.
14. What is 5 times 14?
70.
70. 6 minus 70?
64.
Negative 64. So what is this? What's this mean? Negative 64. What did that just give us?
That's the term of
That's the 15th term.
That's the 15th term of the sequence. Yep.
Are you able